All right, we are continuing on Unit 13, and we are on Notes B. So the review, we just went through this with Part 2 of Notes A. So you can always reference that video again to go through that first page. What I'm going to focus on now for Notes B is the second page. So in the second page is we're going to go through a full process with the standard form, which we are going to start with the axis of symmetry, find the vertex, make a table, sketch it, and answer our questions max, min, domain, range, solutions, and y-intercept. So same process that we did with vertex form. So when we start here with the first example, number 1, I like to identify my variables. A is 3, B is 12, C equals to 9. Then let's go through and we're going to start by finding the axis of symmetry, x equals negative b over 2a. So we have negative 12 over 2 times 3. Negative 12 over 6 equals to negative 2. We take that 2 and we're going to plug it into our original equation. 12 times negative 2 plus 9. All right, we're going to plug this in our calculator. 3 times negative 2 squared plus 12 times negative 2 plus 9, negative 3. So this becomes our vertex. So our vertex we put into the middle of our graph, 2, negative 3. And remember, we go to smaller and to larger numbers. Same as when we did our vertex form. So now we're going to plug our numbers in to our calculator. To get the points that we are going to graph. So now I can graph these points, negative 4, 9, 3, 0. And we have our graph. So using that graph, I can answer the next questions. Is the vertex point down here a maximum or minimum? So that's a minimum because it's the lowest point on my graph. My domain is always negative infinity to infinity for quadratics. And my range is the lowest y value, negative 3, to the highest y value, infinity. When we talk about solutions, we're looking at our x-intercept, and we're looking at how many times my graph crosses the x-intercept. So we have 2 points. So that gives us 2 solutions. And my y-intercept is where the graph crosses my y-axis, and that is at the point 0, 9. What I want you to know and learn too is this y-intercept value here, this 9. If I look back at my original equation, you can see that c equals to 9, and that's always going to be the case. So this value here, c equals 9, is always going to be my y-intercept. All right, so practice 2. We're going to identify a, b, and c. A is 1, b equals to 0, and c equals to 4. So my axis of symmetry, 0 over 2 times 1 equals to 0. We take this number, plug it into our original equation to find our vertex, which is 4. So our vertex is 0, 4. So that vertex goes in the middle, 0, 4. 2 numbers smaller, 2 numbers greater. And we're going to substitute those numbers into our equation. To get our points. We're going to graph our points. -2, 8, -1, 5. Get a graph. All right, let's answer our questions. Max or min? It is a minimum because my vertex is the lowest point on my graph. Domain is always -infinity to infinity. My range is my lowest y value to my highest y value. Looking at solutions, does my graph ever cross my x-axis? It does not, so we have no solutions. And my y-intercept, we know is at 0, 4. But I would know that even without graphing because the y value, 4, is, if I look back at my original equation, is my c value. All right, last example. We have to define our a, b, and c. A is -2, b is 4, and c is -2. So we have x equals -b over 2a, -4 over 2 times -2. So x equals to 1. We are going to take that, plug it into my original equation. And the common mistakes in this is just, you got to make sure you type this in your calculator correctly with those parentheses. So 1, 0 is my vertex, which goes into the center of my table. 2 smaller, 2 numbers bigger. I'll plug those numbers into my calculator here. We have -8. -2. Graph our points. -1, -8. 0, -2. All right. So my vertex now is become a maximum. It's the highest point on my graph. My domain is still -infinity to infinity. My range is my lowest y value, -infinity, to my highest, 0. And how many solutions I'm looking at, how many times does this graph cross my, or touch my x-axis, and that is once. And my y-intercept is going to be 0, -2. Again, let's just connect that -2 is the same as the c value from my original equation. And that is